Hello again. This is the third and the final lecture concerning lists, and in this lecture we will talk about some useful list functions. Okay, so normally these are things that you would do with a list, uh, and these procedures are so common that Python decided that it's a good idea to actually have built-in functions for such procedures. Okay. So we will start with the first function, which is list concatenation. Okay? And as the name suggests, given two lists, okay, A and B, the concatenation of a list will give you a new list that is essentially the two lists joined together. Okay, so two lists joined together. Okay, so you might have noticed that we use the plus symbol for concatenation, and it works similar to strings. Okay, in fact, strings and lists have a lot in common, but anyways, we'll talk about it later on. But we use the plus operator to concatenate. So this is the concatenation operator. Concatenation. Okay, and so in this example right here, A is a list of size 2, and the elements are 1 and 2, and B is a list of size 2 again, and its elements are 3 and 4. So when we do A plus B, right, we get a new list, which in this example we store it in the variable x, and x is a new list that contains values 1 2 3 4. The first two values are from A, the next two values are from B. Okay, simple, right? So it creates a new list from the two lists that are the operands to this expression. Okay, so this is the operator, and A and B are the operands. Okay, so this is essentially what concatenation is. Now, concatenation also follows the plus equals notation. Like you can also concatenate using the plus equals notation. Okay, so plus equals essentially means so like when you say a plus equals 5, this is essentially equivalent to saying a equals a plus 5, right? That's what you say, right? Now, similarly, in case of list, when you say x plus equals 5 6, essentially what you're saying is x equals x plus 5 6, which means whatever the value of x is, the list x, right, concatenate the new list 5 comma 6 with it, and then save the value back to x. So the new value of x would be equal to the old value of x plus 5 6, which means the old elements of x and the elements 5 and 6 appended to that, and then save it in the variable x, right? So previously x was 1 2 3 4, right? When we say x equals x plus 5, essentially what we are saying is x equals 1 2 3 4 plus 5 6, because this is the old value of x, right? Now this equals 1 2 3 4 5 6, which is what is displayed when you print x. Okay, so that is list concatenation, adding two lists together. The second operator that we'll talk about in this lecture is list repetition. Okay, and that is done using the star operator. Okay? It's the multiply, essentially done using multiplication. Okay, repetition is equivalent to multiplication. Okay, and in what way is it equivalent to multiplication? Think of it this way. Okay, let's say you have this expression a equals 5 times 4. Okay, this is equivalent to saying a equals 5 plus 5 plus 5 plus 5. Okay, so 4 times 5, or you can also say 4 plus 4 plus 4 plus 4 plus 4, so 5 times 4, 5 times, right? That's where the times comes from, right? So similarly, you could also say when you have an expression such as um, x equals a plus 5, I'm sorry, a times 5, this is equivalent to saying x equals a plus a plus a plus a plus a, right? And that is, again, that is 5 times, right? So just like that, in lists you can also use the star operator to mean append 3 times. This, in this case, it means append append 3 times, right? In this case, if it's 2, it means append twice, right? Append 2 times. Okay, so just like in algebra, right, the multiplication is nothing but addition with itself, right? That's what it is. Now, so this, in case of lists, instead of multiplication, we'll just call it repetition, because it's not really multiplication, right? It's just repetition. You're repeating the same thing again and again, the same thing again and again, right? Now, you've already seen this syntax before, right? You have seen this syntax before. When have you seen it? When you create a new list, when you create a new list, right, and allocate memory for the list, allocate memory. Remember, when we talked about creating lists for which you know the number of elements but not exactly what the elements are, right? When the elements are unknown but you know exactly how many elements there are, so reserve space to store the ages of 4 people. You know it's 4, so what we do is ages equals none times 4, right? So we have already seen this syntax before. Now we know what it does, right? Now we know what it does. So what essentially it does is, given x equals none times 3, essentially this evaluates to none plus none plus none. Okay, so we have three lists, each of size 1, right? 3 lists, size 1 each, right? And each of these elements are none. Okay, when we append these 3 lists, what we get is a single list with 3 elements. So we get one list and 3 items. Okay, one list containing 3 items, right? So that's what happens when we declare an empty list of size whatever, right? Underneath, that's what happens. It uses this list repetition, uh, and the star is the repetition operator. Okay, so this thing also works with other lists, right? So for example, in the second set of statements, what we have is a new list 5 6, right? And we multiply that with 2, so this 5 6 would be repeated 2 times, right? So what this essentially means is x equals 5 6 plus 5 6, 2 times, right? 2 times, which means the result is 5 6 5 6. Okay, similarly you could say x times equals 3. Okay, so the times equals also works. Okay, by the way, this is a mistake. It would be it would be 5 6 5 6 5 6 5 5 6 5 6, and then again you have 5 6 5 6. That's the correct answer. Okay, anyways, so when you say x times equals 3, what you essentially mean is x equals x times 3, right? That's what it means, right? And this in turn evaluates to x equals x plus x plus x, right? Which means 3 times x, right? Which means each of the x is concatenated with itself 3 times, right? So, and x, as we know, is 5656, right? That is the value of x. So this value is this value replaces all the x's here. Okay, this value replaces all the x's. So essentially what we have is 5656 plus 5656 plus 5656. Okay, so the resulting list is 5656 5656 5656, right? That's your resulting list. So this is list repetition, okay, using the star operator to concatenate a list with itself. Okay, the third type of function that we'll talk about is not function per se, but useful operators is the membership operator. Okay, and just so you understand this, that these membership operators or the concatenation or repetition that we talked about before are not only applicable for lists but also for other types of data structures. Okay, for instance, you already know that you can concatenate two strings, right? You can also apply the repetition operator on strings. Okay, so when you have a string, let's say you have a string called title, uh, uh, or something equals some title, I don't know, something, that's your string, right? So when you say title times 3, what you get is something something something, right? So the concatenation, the repetition operators would also work on other data structures, not just lists. Okay, and it might help you to understand that actually strings, you can think of strings as lists. Okay, strings are nothing but lists of characters. Anyways, we'll talk about strings later on, but for now, uh, just remember this, that membership operators and the other operators that we talk about here are not only applicable to strings but also other types of data structures. Okay, so with that in mind, let's see what a membership operator is. Okay, a membership operator checks whether or not an operand exists in a data structure. Okay, exists. So there are two membership operators, in and not in. Okay, now in evaluates to true if it finds a value in a list. By the way, it can also be any other data structure. It can also be a string. Okay, but since we are talking about lists in this lecture, we'll just consider lists, right? So the in operator evaluates to true if it finds a value in the list, and if it does not find a value, it says false, right? uh, Similarly, there is this not in, right, which evaluates to true if it does not find a value and false otherwise. So not in is the opposite of in, right? Obviously. So let's see a few examples of how we apply in and not in. Okay? So in the first example, when we say x in the list 359, okay, this evaluates to true if the value of x, whatever the value is either 3 or 5 or 9, right? So this can also be written as if x equals 3 or x equals 5 or x equals 9. Okay, whatever the value of x is, let's say x equals 5. If x equals 5, this expression will evaluate to true, right? And if let's say x equals I don't know, 1, x equals 1, right, then this would evaluate to false. Okay, so it depends on the value of x. What this means essentially is if x is if x equals 3 or x equals 5 or x equals 9, right? So if you had to use if you don't use the n, the other way of finding this, right, is as follows. Okay, so let me go back to this line. So let's say you have this list called L. Okay, L equals, I don't know, 359. Okay, and you want to find whether a value x exists in 359 or not, right? So x is either 3 or 5 or 9. So the way you would normally do it in lists without the in operator is as follows. You would say uh, for v in, you know what, let's call it values, that's the name of the list. Okay, so you say for v in values, if if x equals v, right, you return true, right, else you return false. Okay, so let's say you have like a function, right, you have a procedure for this, you have a function defined. So how would you find if a particular value, whatever the value is, right, x exists in a list of values or not? What you normally do is for v in values, right, if x equals v, then you return true, which means yes, it does exist, right? Else, if you're completely out of the loop and you still haven't returned true, it means there's only one possibility, which is it's false, right? Which means the value x does not exist in the list of values. But the idea is the in operator makes it simple. So instead of having that much line of code, you can do it simply using the in operator. Okay, uh, internally, right, under the hood, it still does all that. Okay, but you don't have to explicitly type it out, it will do it for you. Okay, so that's what's happening here. Okay, similarly, so just like here, we have an expression and a list, right? The expression, I'm sorry, and a variable and a list. You can also have a constant and a list of variables. Okay, so in this case, we're trying to find, okay, in the, excuse me, second example, we are trying to find if the value 3 exists in the list xyz. Okay, and remember xyz are all variables. Okay, so this can also be written as if x equals 3, or x equals, I'm sorry, 3 equals x, or 3 equals y, or 3 equals z. Okay, and this again, this evaluates to true if either x or y or z is 3, and if none of these variables have 3 in them, right, or they are, if neither of these variables are 3, this expression, this whole expression evaluates to false. So you normally use this expression together with an if statement. Okay, now just on a quick note, you have already seen this in operator. Do you remember where you've seen it? Okay, in for loops, right, how do we write for loops when the number is the when you know how many times it will run, right? So you say for I in range, let's say 100, so a loop that runs 100 times, this n is the same as this n. Okay, it's essentially the same thing. So just like a list is a data structure, a range is also a data structure. Okay, you can think of a range as a list, but the only difference is it goes from 0 through 99. So you can think of a range as a list uh, of numbers from 0 to 99, right? Although it's not exactly the same, but it certainly helps if you think of it this way, right? So when you say for I in range, it essentially means I takes the value 0, 1, 2, so on and so forth. Okay, anyways, let's not digress. So in the third example, right, we have s in list A, C, E. Okay, which as you get it by now, I'm sure, can also be written as s equals A, s equals A, or s equals C, or s equals E. Right? Now this whole expression evaluates to true or false, right, depending on the value of s, right? If s is either a or c or e, it evaluates to true, else it evaluates to false. Okay. Now similarly, you have this not in, which is exactly the opposite of the in operator, right? So essentially it's this thing with a not added before. Okay, so that's it, right? So s equals a, or s equals c, or s equals e, not, right? And as you might have guessed it by now, this evaluates to true. This evaluates to true if s is not a or c or e, right? So the other way of writing it is, if s not equal to a and s not equal to c and s not equal to e. Okay? And this expression evaluates to false, right? It evaluates to false if s is any one of these, right? So if s is a, or s is c, or s is e, this expression right here will evaluate to false. Okay. Now it's important to understand that the operator, the in operator or the not in operator, only checks whether an operand exists or not. It cannot find the index position where the operand is found. Okay, it cannot find the index position. So if you have a list, right, if you have a list of students, let's say a list of numbers, and you want to find at which position do I have a certain number, right? So let's say you have a list of 1 2 3 4 5 6 7 8 9 10, and we have variable x, whatever the value of x is, I don't know. All I need to find is two things. Okay, if f if x exists, if x exists in the list, right, let's call it values, exists in the list values, and if it does, where? The index. Okay, so index, remember, index is 0 1 2 3 4 5 6 7 8 9, right? So if x exists, where does it exist, at what index? Okay, so the in operator or the not in operator, they will not find the index for you. They will only tell you if x exists. They will only answer the first question. Okay, the second question they will not answer, right? In order to get the second question, or rather the answer to the second question, you have to go follow the previous approach, in which you say for v, not even that. Okay, you can't even say that. You have to use uh, a loop in which the read modify approach. Okay, so you say for I in range, whatever the length of values is, right, length of the list is len list, right, length of the list, if if uh if list, you know what, it's not list, it's list is a bad name because list is a Python reserved keyword. So len of values, let's say the list is called values. Okay, if values if values I equals x, return I. Okay, so if you had to write a function, that takes as an argument a list and a number, okay, and a value, and all you have to say is at what position, at what index does that value exist in. Okay, so this would be your function. Okay, so you say, let's say def function. Okay, so you return I. Function takes two arguments, a list of values and a number x. Okay, so to summarize this part, the in or the not in operator, they'd only tell you if an operand exists or not. Okay, it cannot tell you the index position if it exists. Okay, so let's say some more examples of membership operators. So this following example prompts the user to enter a name and checks whether if it exists or 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 if it doesn't exist, rather, in the list of names. And the list of names is John, Maria, Anna, George, and Tess. Okay, so I would prompt the user to give me a name, right? And this is how I prompt, right? So I say name equals input, enter a name to search. So let's say the user enters Jack, enters Jack, and presses the return key. Okay. Now I say if name not in Y, print name not found. Okay. So in this case, name is Jack. Okay. So what this statement means is if Jack not in Y, which is true, Jack is not in Y, right? So if Jack, this expression name not in Y evaluates to if Jack not in this list, John, Maria, Anna, George, Tess. Okay, which in turn evaluates to true because yes, Jack is not in this list, right? Jack is not in this list. So I will say name not found. I'll print name not found, which evaluates to John. I'm sorry, Jack not found. Okay. If on the other hand, I press, let's say, John, I enter John, right? And the name not in Y will evaluate to false. This will evaluate to false because John is in the list. So the John not in the list will evaluate to false, and then we won't print anything. Okay. Here are a few other examples. So in this example, we have a list X containing the values 1, 2, 3, 4, 5, 6, right? And then we ask the question, is X in 3? So we say if X is in 3, then you print this, right? And as you might have guessed by now, this will evaluate to true, right? This will evaluate to true because 3 is an X, right? That's 3. So it will print it exists. It will be printed, okay? So this expression evaluates to true. In the second example, we have a list Y, again, containing the elements John, Maria, Anna, George, and Tess. And we ask the question, if George is in Y, right? And indeed, George is in Y, right? That's George right there. So this will evaluate to true. This expression right here will evaluate to true, right? And as a result, the if condition would be satisfied and this line would be printed. It will say, I found George. Okay. Now, the next operator that we'll talk about, rather function, it's not a function, it's not an operator, it's a function. The next function that we'll talk about is the max function. And the max function finds the maximum value for you. Okay. So the general form of the function is max and then a set of parentheses and the name of the list. This is the list name, right? Okay. So simple, right? So in this example, we have the list A, which contains the items 3, 6, 10, 2, 1, 12, and 4. When we say print max of A, the output is 12, obviously, because that is the largest element. Okay. You can also use this max with the sublist notation, because essentially a sublist is also a list, right? It is a slice of a list, but it is also a list. So when you say maximum equals max of A 1 colon 4, what happens is it checks, it sort of gets a new list starting from the first index, which is this one, and ending before the fourth index. So this is 0, 1, 2, 3, 4. So this max, this A of 1 through 4 will take the sublist 6, 10, and 2. That's your sublist, right? So max of this sublist is obviously this number right here, 10, and that's what it will output, right? 10. Uh, Now, in case of strings, the max would be the lexicographically higher, largest. Okay, which means lexicographically would mean if you arrange these words in a dictionary, right? What is the word that comes the last? Okay, so if you were to write these down in a dictionary, let's say, right, or if you were to find these words in a dictionary, the first one you would be able to find would be the Aphrodite. That's number one, right? Because it's A and then a P, which is again same as this, but then Apollo has an O, whereas Aphrodite has an H, which comes before O. So in a dictionary, Aphrodite would come before Apollo, right? So we say that Apollo is larger than Aphrodite. Okay, because in a dictionary, Aphrodite would come before Apollo. That's why we say Apollo is larger than Aphrodite. Okay, so in this list C of Greek gods, right, you have Apollo, Hermes, Athena, right? Obviously, you can see that Hermes is the largest, so to say, because in a dictionary, Hermes would come at last because it starts with an H. Okay, so if you print max of C, it will output Hermes. Okay, now just like the min function, the max function, we also have the min function, okay, which obviously returns the minimum value in a list. So in this example, the list A contains the items 3, 6, 10, 2, 1, 12, and 4. When you print min of A, it prints the minimum value of in the list, right, which is in this case 1. So this outputs 1. Similarly, you can also find the minimum value in a sublist. Excuse me. So in this example, we find the minimum value in the sublist 1 through 4, right? Remember, and the indices are 0, 1, 2, 3, 4, 5, 6, right? And the sublist 1 through 4 would start from here and end before 4, right? So that's your sublist 6, 10, and 2. And obviously the minimum is 2, right? That's your minimum, and that's what it outputs, right? 2. Finally, in the third example, we have this list again, list of Greek gods, Apollo, Hermes, Athena, right? And the minimum would be the lexicographically minimum, right? Lexicographically minimum or smallest, which means if you were to look for these words in a dictionary, which word would come first? And obviously Aphrodite would come first because it is an A and a P and then an H. The closest one is an A and P, but then it's O, so that comes later, right? So this is the first one. And when you print min of C, the list C, it outputs Aphrodite. Okay. Now, just so you remember this, what this min and max does under the hood is go through each and every element in the list and find you the minimum, right? So if you were to write your own function, your own min function, how would you write it? Okay, or maybe your own max function, right? So let's go for max. Okay, so how would you write a max? So you have a list. Let me clear this. You have this list. Let's say A 3, 6, 10, 2, 1, 2, 1, 12, and 4, right? So let's say you want to find the maximum value in that list. So you have to say you have to you define a new function, right? So you say def max, which takes the list as an argument. So let's say A, that's your list, right? And what you do is you create a temporary maximum, right? So you say, let's say largest equals 0. That's your temporary maximum, right? And then you say for value in A, so for each value in the list A, if value is greater than largest, then you update the largest, right? So largest equals value, right? And then you return the largest. Okay. Now this is, of course, this is assuming that A is all the elements in A are positive. Okay, if they are negative, then this would fail. But this just gives you an idea of how you define your own max function. Okay. If you want to make it a little more robust, what you do is, instead of setting the largest to 0, you'd set the largest to be the first number. Okay, you say largest equals A0. Okay, if you do that, it's a much more robust way of doing it. Okay, because now A can be any number, it can be strings even, right? It can be anything, right? But this is how you would define your own max function. Similarly, you can also define your min function in this way, right? So all you need to do is, largest, you would say smallest equals A0, and then if value is less than smallest equals value, return smallest. Okay, so that's how you write your own max or min function. But because these functions are so common, right, these are predefined in Python, so they're already done for you, so you don't have to write them yourselves. Okay, the last function that we'll talk about, actually the second to last, is called sort. Okay, list.sort. Now this function is a bit different from the previous ones in that it uses the dot operator. Where have we seen the dot operator before? Remember, when we append, right? So let's say we have a list of values, and we have said, if you want to append a value to this list, you would say values.append, right? That's where we have seen the dot operator before. So just as a rule of thumb, whenever you want to modify the original list, okay, you would use the dot operator. Okay, so in this case, the sort function, okay, the general form of the sort function is, it uses the dot operator, the name of the list, right? Name of the list, the dot operator, and the sort function. Okay, and then it takes an optional argument, reverse equals true. Okay, this argument specifies if the sorting would be done in the ascending or descending order. Okay, if the reverse is set to true, it would be descending order. Okay, and if the reverse is false, the reverse is false. Okay, it does ascending order, and that's the default. Okay, ascending order is the default. Anyways, so just to remind you what sort is given a list of random numbers, unordered numbers. Sort would order the items, let's say the items in a list in an ascending or a descending order. So in this example, you have this list A containing the elements 3, 6, 10, 2, 1, 12, 4. Now obviously this is unordered, right? There is no order to it. This is unordered. So when you say a dot sort and then you print A, you will see that the elements are now ordered in ascending order. So you first have 1, which is this one, and then you have 2 and 3, which is this one, and then 4 comes here, right? 6 comes here, 10 comes here, and 12 comes here. So it is the exact same elements in the list. Okay, the exact same elements, except they are now in ascending order. Okay, as a quick note, if you have duplicate elements in there, they would still be there. Okay, so if you have, let's say, 2 comma 2 comma 1, you still have 1 2 2 3, right? So it has the exact same number of elements, right? But they are only ordered differently. Okay, that's what the sort does. Okay, and also it modifies, as you might have noticed, it modifies the original array. Whenever you use the dot operator, it always modifies the original array. Okay, so modify the original. Okay, you can also sort in reverse order. All you have to say is, in the sort, in the parentheses right here, right, in the parentheses, all you have to say is reverse equals to, and then it would output in the descending order or reverse order. Okay, so same array A, right? When we say sort dot reverse, it would sort the array in reverse order. So it will say 12 10 12 10. So starting in descending order, so starting from the largest all the way to the smallest. Okay, now as usual, if you have a list of strings and you sort that list, it would be sorted in the lexicographical or dictionary order, right? So obviously Apollo comes first, so that would be Apollo because it starts with an A. Then it would be Dionysus, and finally Hermes, right? That's Hermes right here. Okay, so again, sorting a list of strings would sort the elements in a dictionary order, which means the item that you'd find in a dictionary first would be first in the list. Okay, there is another way of sorting a list in which you keep the original list intact and you make a copy, right? So there is another way, which is to make a copy of that list, and that does not use the dot operator before. Okay, it uses a function, and the function is called sorted. The function takes a list, right? The name of that's the list variable, and it also takes an optional argument called reverse, just like before. Okay, so you may or may not use this argument. If you don't use this argument, the default is false. If you use this argument, you have to specify that reverse is true, and then it would sort in a descending order. So anyways, in this example, you have this list A containing the elements 3 6 10 2 1 12 4. So if you want to create a new list which has the exact same elements as this list before but in a sorted order, all you do is you'll say B equals sorted A. Okay, so when you print A, it still has the exact same elements in the exact same order. So 3 6 10 2 1 12 4, 3 6 10 2 1 12 4, exact same order. But B has now changed. Okay, so B is a new list which has the same elements but in the ascending order. So you start with 1 2 3 4 6 and then 10 12, right? Similarly for strings, you have a list of Greek gods, and you create a new array D from the unordered array C, right? So you say D equals sorted C, but reverse equals true, which means sort in descending order. Okay, descending. Okay, which means largest to smallest. Okay, so what is the largest here? Largest is Hermes, which starts with an H, right? Because that Hermes would be the last one to appear in a dictionary amongst these three. So Hermes would be last, right? Which means it is the greatest, which means it comes first because we are sorting in a descending order, right? The next one in a dictionary would be Dionysus because it comes before Hermes but after Apollo, right? So the next one would be Dionysus, and the last one, which comes the first in the dictionary among all these three, would be Apollo. Okay, and as I said before, the original list remains unchanged. So C still contains Hermes, Apollo, and Dionysus in that order. Okay, so the original list C is unchanged, but the new list D contains the items in list C but in a descending order because we specified the reverse to be true. Okay, so that concludes all there is. That concludes the lecture on lists. We won't talk about lists anymore for now. In the next lecture, we will talk about a new data structure which we call dictionary. Okay, and it is very similar to lists. So it if you understand lists, dictionaries won't be too hard. Uh, and I will post a few practice problems on lists, and possibly when I'm done with dictionary, I'll post the next assignment. As usual, if you have any questions or any problems, just send me a mail, and I'll try to set up a Zoom appointment as soon as I can, so that we can fix whatever problem you have. Okay. Right. Till the next lecture. Goodbye.